Hello and welcome. My name's Kylie Walker. I'm the Chief Executive Officer of the Academy of Technology and Engineering. And tonight, I'm delighted to introduce you to our extraordinary new fellows for 2020. Thank you for joining us.
Yanyan Yagu Nanadara Yalamandi. Hello and good evening from Ngunnawal country and welcome. My name is Richie Allen. I'm a Ngunnawal leader. I'm here to perform a welcome to country. A welcome to country is an ancient tradition practiced for thousands and thousands of years. You never entered into anyone else's country unless you're invited. Our sun is the dreaming on Ngunnawal country. First of all, I'd like to pay my respects to the Ngunnawal ancestors. It's their footprints they're left behind on this beautiful country we call Canberra that I follow, my family follows, and everyone follows in Canberra each and every day of their lives. It's the safe footprints that we follow. I'd also acknowledge the Ngunnawal elders, past, present, and also like myself that are emerging in the next generation to keep the traditions alive. I'd also like to acknowledge the other Aboriginal and Torres Strait Islander countries out there and the countrymen and women and thank them for the contribution they make to the lives of every Aboriginal and Torres Strait Islander person and non-Indigenous person as well. Nanadara Yalamandi Yaramulan. Hello and welcome to Ngunnawal Dreaming.
I'm joining you tonight from the lands of the Ngunnawal people. Welcome from wherever you are joining us as we welcome our new fellows and recognise the impact their work has had and will continue to have. We do so while acknowledging the deep knowledge forever embedded in traditional custodianship of country and the most ancient cultures on the planet. We honour Aboriginal and Torres Strait Islander elders and innovators of the past and present. Tonight's show is all about introducing you to some amazing individuals who we're inducting into the Australian Academy of Technology and Engineering. Our fellowship is comprised of technologists, scientists, entrepreneurs, engineers, directors, leaders. The work of our fellows has shaped the present and the future, and our 2020 new fellows are no exception. They each bring with them extensive expertise from across academia, government, industry, and the not-for-profit sectors, each having made significant contributions to growing Australia's applied science, technology and engineering capability. So please, now join me in welcoming this year's new fellows to the Australian Academy of Technology and Engineering.
I'm John Curtin, Distinguished Professor Kingsley Dixon at Curtin University here in Western Australia. My great interest in botanical and ecological research is saving threatened species, repairing damaged landscapes, and connecting with Indigenous communities across Australia in a shared journey towards improving the way that we manage, protect, and enhance the wonderful natural assets of this extraordinary place we call home. When I started my research in the 90s, the world was a very different place. Today, we have lost more plant and animal species in this continent than we have in recent evolutionary history. How my work will go forward and with my partners, not only here but globally, is that we're going to be rebuilding landscapes. We're going to be saving species and putting them back into context. If we don't do this work and we don't get to this work now, we will continue to hemorrhage biodiversity loss, which is a loss to humanity, it's a loss to future generations. And importantly, for Indigenous cultures, particularly Indigenous people in Australia, they identify with the landscapes, the plants and the animals, and a loss of those is a loss of their cultural identity. So the journey ahead is a hard one, it's a long one, but it's one where good science will make a change.
My name's Gordon Naylor and I'm very pleased to be joining the ATSE organisation as a fellow. It's quite an honour. My original background is as an engineer, but I've had a long career working in global biopharmaceuticals. My career has been around bringing technology to life within a business. Over some 30 years that I've been part of CSIRO, I've been closely involved in the transition of that organisation from being a technically excellent part of government here in Australia to being a world leader in the biopharmaceutical space. More recently, I led the turnaround of a business called Charise, which is CSL's vaccine business. We brought to life a new technology which has allowed significant improvement of influenza vaccines for the first time in many years. I'm passionate about what these technologies can do for the world. But what gets me really excited is seeing people within these organisations, people who are technically very, very capable, and helping them to realise the potential of what they can do and what their technology can do, bringing that to life in the real world.
Hello, I'm Vicky Chen. I'm the Executive Dean of Engineering, Architecture and IT at the University of Queensland. My research is advanced technologies in membrane separations and the development of nanocomposite materials. The other big focus of my work is also in terms of gas separation, and that's particularly removing CO2 from emissions such as flue gas from coal-fired power plants, new clean energy sources such as hydrogen, and also cleaning up natural gas so that it could be utilized in the water context of the industry or energy sources for homes. I think that what's exciting is the areas that I work in is really impactful in terms of improving the environmental sustainability of the community, and not only a local community, but the communities worldwide.
My name is Simon Ringer. I work at the University of Sydney in the School of Aerospace, Mechatronic and Mechanical Engineering. I'm a materials engineer, and materials engineers think a lot about the structure of materials, the atomic architecture, if you will, and the connection of that to the properties and the performance of the material. In my team and in the work that I've been doing, we've been thinking a lot about processes around atomic clustering in metals and in other materials, and how we can trick up and drive those clustering reactions. As we learn to harness this clustering reaction in these materials, we find that, for example, we can develop materials with very high strength. Normally, as you develop high strength materials, you lose something on the ductility and the malleability of the material. We've been able to design materials high strength and high ductility, which allows us to lightweight structures. One of the really exciting things that's happening in my field is an enormous disruption around additive manufacturing. The idea that we can build materials layer by layer into exquisite complexity in 3D by using thermal gradients and stress gradients that are actually off the charts from conventional manufacturing. It's a whole new way of building materials, and it's something that Australia is poised to do very well in. It's a great honour to be elected as a fellow. It's also exciting to think about working with other leaders in technology and engineering to think about the distinctly Australian story going forward.
Hello, I'm Renate Egan. I'm a Professor of Engineering at the University of New South Wales and the Chair and co-founder of a successful startup called Solar Analytics. The focus of my work is to make solar more affordable. Solar is already the cheapest form of new energy generation. I operate from the University of New South Wales, where I lead a program in advanced photovoltaics, developing home energy management systems for solar homeowners so that they can make the most of their investment in solar. Solar energy technologies are really just at the beginning of their evolution. We see the whole generation of solar, the material itself, changing. We're working on new materials and new formats and new aesthetics, so it looks different. The world is in an energy transition. We need to move to low emissions forms of energy generation. Solar is already the lowest cost. Australia is well positioned to lead the world in energy integration, in battery storage, and in hydrogen generation.
Hi, my name is Andre Luden. I'm the director of one of the research institutes of the University of Adelaide. This institute is all about using the power of light to make the world healthier, wealthier, and safer. I've got another hat. I'm also the managing director and co-founder of a small startup, CryoClock Proprietary Limited, which is trying to take some of these precision sensing technologies and get them out to the market. The real heart of my research area is the development of new precision measurement technologies. And so we're trying to build things where we're measuring more completely, more accurately, more precisely, or faster than has ever been done before. One of the things I've done is built the world's most accurate clock. It's so good, it will only gain or lose 1 second in 40 million years. Now, immediately you'll all think that, what's the good of such a thing? But it turns out that if we join that with another amazing Australian innovation, the Jindalee over-the-horizon radar system that Defence operates, this keeps all Australians safe by surveilling the north and west of our country. The incorporation of an incredibly good timing device actually means that this radar works better than it could before. We can see smaller things further away, and that makes us all a little bit safer as a result of research that's been going on in my lab.
My name is Charise Sadek. I'm a professor of computer science at the University of Queensland. My work is really at the intersection of business and technology. My work is focused on data management, both from a technology as well as a people perspective. I love the diversity that comes with these disciplines. It's the diversity of perspectives, the diversity of disciplines, all of these advancements through disruptive technologies such as artificial intelligence, machine learning, and data science. I think this year has clearly revealed to us the challenges and opportunities of our collective digital futures. I'm actually really excited to be part of this game-changing period in history.
My name is Shaoxin. I'm a professor of civil engineering and the current head of school at University of Technology, Sydney. The area in civil engineering I'm specifically working on is ground geomechanics. It's quite exciting because the problems, the materials we're dealing with are inherently complex, and also because we keep going deeper into the ground, high into the sky. My research focus is on developing computer models for predicting deformation and stability. I call it geomaterials, which is basically soils and the rocks. These materials often serve as foundation for structures we know, such as bridges, buildings, tunnels, highway and railway embankments. My research interest is to look at the multi-physics in these materials, how it affects the engineering properties of these materials, and to develop computer models to predict the behavior of these materials. All this is quite exciting because on one hand, we have a difficult problem to solve. On the other hand, we're trying to go bigger and faster and larger. It's an area really exciting for research. Civil engineering, it's a field where we do change the world.
I'm Stuart Khan, and I'm a professor in the School of Civil and Environmental Engineering at the University of New South Wales. I work in water and wastewater engineering. I'm particularly interested in urban water management, things around drinking water treatment, wastewater treatment, and increasingly how we take what we've always considered to be wastewater and reuse it as a purified, recycled water source. Improvements in the way that we manage urban water supplies are crucially important going into the future. We're dealing with things like climate change, population growth, uncertainty around things like the global pandemic that we're currently living through now. So we need to make sure that our water supply systems and our wastewater management systems really are fit for the future. We're discovering new importances for the way that we manage wastewater all the time. Only this year, suddenly wastewater is in the spotlight in looking at the presence of the SARS-CoV-2 virus, the COVID-19 virus, and what it can tell us about epidemiology, about patterns of the disease in the community. The real excitement in water engineering now comes down to closing the loop. We've always thought of water as a linear process. We take water in from our drinking water catchments, we use it in our cities, and we discharge it back out into the environment. The thing I love about working in the water industry is that it is so important and people understand the importance of it. We can't keep going the way that we've been going, and we need to find more sustainable solutions to enable our cities to continue to progress and to continue to thrive.
My name is Trevor Danos. I'm a lawyer and a company director, and I'm an adjunct professor at UNSW, where I chair the Science Advisory Council. The work that I currently do is very much focused on governance and leadership, connecting the dots, bringing people together, finding new sources of funding, breaking down the barriers between academia, industry, and government. So the work that I do, I find really enjoyable. We can identify new ideas and we can implement those ideas. In electricity, we're looking at asset acquisition and asset maintenance, looking to refine the ways to deliver power, large battery cells, electric vehicles. Health in the future will be very much driven by what has happened with COVID. We're looking into new models of care. We're looking at designing and building new infrastructure that is future-proof. It's about reminding people of the importance of science and technology and how it plays a key role in the welfare of society and the well-being of society.
My name is Dr. Sarah Pearce and I'm the Deputy Director of CSIRO Astronomy and Space Science. I work in astronomy, and what I do there mainly is I am preparing to build the Square Kilometre Array, which is Australia's next big mega science project. But I also work in space, where I lead CSIRO's space programme. The Square Kilometre Array is an international project with 15 countries involved, and it will build 2 giant radio telescopes, one in South Africa and one in Australia. In Australia, we'll have 130,000 low-frequency antennas spread across 60 kilometres of desert in Western Australia, which will allow us to look back to the dawn of time, not long after the Big Bang, when the first stars and galaxies started to shine. The most exciting part, I think, about working on the Square Kilometre Array is being in right at the very beginning of a decades-long process. We've just set up an intergovernmental organisation, a treaty organisation for the SKA, which we expect to last for the next 50 years. And so I hope, even when I retire, I'll be able to look back and say I was there right at the beginning of that.
Hi, my name is Cordelia Celomuya, and I'm a professor of chemical engineering at University of New South Wales in Sydney. And I'm also the research and commercialization director for Future Food Systems CRC. The focus of my work is looking at how we can optimize processes, particularly in the spray drying area, Spray drying is a process to convert liquid into powders, and it has been used a lot in a number of industry, the dairy and food industry, pharmaceutical industry, and others as well. What we're looking at is to look at how we can optimize this process, but also to see if we can actually create a number of different other materials using this technique. The exciting thing about this field is to look at how we can push the boundary of how we produce and manufacture food, and also how we can optimize the formulation that we use. This work is the freedom that we have to explore topics of research that probably are pushing the boundary. At the same time, I'm also excited to work with industry to look at applied research, because this is a way that we can actually contribute to the society in terms of getting our research outcomes to the wider world.
My name is Professor Darren Martin. I'm a materials scientist and I work at the Australian Institute for Bioengineering and Nanotechnology at the University of Queensland. Well, we go from basic material science discovery all the way through to products. Over the years, we've worked on everything from new polymers to new nanomaterials to materials based on sustainable building blocks. So in other words, plant-based high-performance materials. We work with the Dugalunji Aboriginal Corporation, who are based up in northwest Queensland. We've been working on nanofibres of cellulose from spinifex, this sacred ancient grass. We've discovered that these fibres could have great utility as reinforcers in things like recycled cardboard, ultra-thin natural rubber latex condoms and gloves, and even more recently as flow modifiers in injectable medical therapies. There's been a really strong and palpable shift away from petrochemical-based materials to renewables. It all comes down to respecting traditional knowledge and working on cutting-edge technologies, but doing it in partnership in a way that provides long-term benefits.
My name is Robert Klupax. I'm the CEO of the Bionics Institute. I started very much in drug discovery, drug development, moved into cell therapy with embryonic stem cells, and then subsequently moved into the field of oncology with antibodies. And lastly, in the last 5 or 6 years, I've been heavily involved in the development of new implantable medical devices. We've got areas of key interest which involve neural stimulation. But I think into the future, we are very open. Our great strength is being able to sit down with a clinician and they come to us as a group of creative engineers and they say, this is the problem. And we then get together and we say, what, with our skills, perhaps we can do this and this and get an interactive collaboration between a clinician and an engineer to create a solution. What I love is each time I come into work, we're working on a real life problem with a very clear goal to move it from the bench, from discovery into something practical. I get to walk into a lab every day and sit and talk crap with engineers and doctors. It's fun, man.
My name is Eleanor Huntington. I'm the Dean of the ANU College of Engineering and Computer Science. I have no idea what I want to be when I grow up, and in fact, I never have. I have spent most of my career working in large teams that try to do world-changing things. My work these days runs on 2 parallel threads. There's the technical work that I do around quantum computing, and then there's the intellectual work that sits behind my role as a dean. As Dean of Engineering, the thing that I very much enjoyed there is exactly this idea about convening a train of thought and a series of conversations about the role of engineering and computing and the use of technology in the world. What keeps me coming back is always the sense of moving forward, the sense of making progress and working in teams. It's the thing that gets me out of bed every day, and it's the thing that has always motivated the way I go about approaching everything in life.
Anton van den Hengel. I'm a professor of computer science at the University of Adelaide, but I'm also the director of the Australian Institute for Machine Learning and a director of applied science for Amazon here in Adelaide in South Australia. My particular avenue of research inside machine learning is about the intersection of language and image analysis. And that's a powerful place to be because images are a form of information that occur naturally. They're not symbolic, they're completely real, whereas language is a symbolic and artificial form of information that tells us a lot about the way that people think. And to be able to bring those two different kinds of information together really means that gives us an insight into the way that the human mind works in all of its strengths and frailties. Working at the intersection of those two kinds of data is an incredibly powerful insight into the human mind.
Hello, I'm Professor Sally Gross from the University of Melbourne. I'm a biochemical engineer and I'm interested in producing food and pharmaceutical products and how we can improve the processes that make those products. These products include cheese and yogurt that we make with the Australian dairy manufacturing industry, which is worth around $3.3 billion annually to the Australian economy in terms of exports. We also help to make new medicines. For example, in Australia, we extract painkillers from poppy. And this type of activity, this manufacturing, is also worth around $8.9 billion to the Australian economy. I'm based at the University of Melbourne at the Parkville campus in the Department of Chemical Engineering and also at the Bio21 Molecular Science and Biotechnology Institute. Well, more than ever before, we need to have smart and sustainable processes to produce food and pharmaceuticals. It's estimated that we'll have a further 2 billion people to feed by the year 2050, and we need to do that sustainably. The recent pandemic has shown how important it is that Australia is able to manufacture its own products. And an example of this is medicines, and we currently import around 90% of our medicines. Both these areas of manufacturing require us to make the most of the raw materials. So that might be turning milk into cheese or poppy extract into high-value medicines. And it's important that we, in general, try to decrease the impact of these processes on the earth. And one of the ways we can do this is by helping manufacturers to evaluate and adopt different types of technology. And this can help manufacturers to address these broader sustainability goals. I'm delighted to have been made an ATSE Fellow. It's a great recognition for the hard work that I've put in with my team over the years. And I'm looking forward to contributing to the Academy and also helping to solve some of the challenges that Australia faces in the future.
My name is Professor Mark Stewart. I'm the Director of the Centre for Infrastructure Performance and Reliability at the University of Newcastle. I am most interested in risk-based decision-making for engineering systems that are subject to extreme events. And this is particularly about built infrastructure. And when we talk about extreme events, I'm really focused on security, terrorism, and climate change. When people think about extreme events, there's a lot of worst-case thinking, there's a lot of risk aversion, there's a lot of hyperbole. And my role in looking at risk assessment is to look at the evidence, where we try and weigh up the risks, costs and benefits of taking action and what sort of action do we need, whether it's to reduce the risk of terrorism or to reduce the effects of climate change. One way that we can have what we call climate adaptation engineering is how we can design our buildings, our bridges, our highways, our transport networks to be less vulnerable and more resilient to a changing climate. I like it that if I have an idea, I can follow it, I can devote time to it. I have university, which allows me to do that. And it allows me to go into very different directions that a civil engineer normally wouldn't be involved in. And I think we can change the world one conversation at a time. Nothing too dramatic, but just one conversation at a time. And that spreads influence. And that's something I really do feel strongly about the work I'm doing here.
I'm Dr. Steve Jeffries. I've had a very diverse range in my career of roles, but I would like to think, I guess, that my expertise or my passion is all about crop genetics and plant improvement. And so I've worked 36 years in the grains industry, R&D grains, and with a primary focus on crop improvement. The primary focus of my research work has been on the improvement or crop improvement, and more specifically on the improvement of grain yield, pest and disease resistance, and the marketability of Australian winter cereals. The greatest or things that we're proudest about is the pioneering of the adoption of molecular technologies in the application of the development of new varieties globally. I've worked the majority of my career in the field of crop improvement, and the great thing that I love about it is impact. You can really see, measure, witness the impact that you make.
Hello. My name is Vanessa Torres. I'm currently Chief Technical Officer at South 32. I was born in Brazil and chose to be an engineer when I was 5 years old, inspired by my grandfather, who was an engineering professor. That dream led me to study chemical engineering and do my master's and doctorate degrees in minerals engineering. Our purpose is to make a difference by developing natural resources, improving people's lives now and for generations to come. The most exciting thing in my view in the future of mining is that the fast pace of the development and integration of environmental and digital technologies will enable future mining operations to be carbon neutral. I love developing new technologies and ways of using these technologies to make our work safer, cleaner, and more productive.
Hi, my name is Richard Belt. I'm a principal of the Nous Group and a former department head in the Victorian Government. My career in stimulating energy innovation with a technology focus towards zero carbon really started when I was a trainee engineer, working on the steelworks, looking at the amount of raw materials that were being consumed, and something told me that we needed to do that better over time. What's exciting about this work is that we have now moved into getting to grips seriously with how you scale up renewable energy, cleaner uses of fossil fuel, better energy efficiency to get this circular net zero economy moving. We're really seeing big investments that actually turn these, what were once really pipe dreams, into reality. That's what's exciting. And what's also both exciting and daunting is my one-year-old granddaughter. She's going to be 81 when the next century comes into view. And if we don't get this right, the kind of world she'll be living on makes me shudder to think about. What I really love about what I do is it's just an enormous motivating force in my life to leave a legacy.
Hi, my name is Hala Zreiqat. I am a professor of biomedical engineering at the University of Sydney, director of the Australian Research Council for Innovative Bioengineering. My work involves developing synthetic approaches to regeneration of musculoskeletal tissues, orthopedic, dental, really anywhere in the body that has bones, tendons, ligament, cartilage. We are developing the next generation of nanorobots or nanomaterials that can be used for what we call theranostics, for targeted delivery of cancer, for instance, Parkinson's, Alzheimer's. These nanomaterials are magnetic and they can be functionalized so that they release the drug where we want them to release it. So you don't have to rely on chemotherapy anymore. What I think has led to the success that we have in our research is purely and entirely believing in the early career researchers that we have in Australia. These are wonderful people, and we need to also appreciate the importance of diversity in culture, ethnicity, and disciplines. These combined leads to successful research.
Hi, my name is Lim Chang. I'm a professor in hydraulics at the Department of Civil, Environmental and Mining Engineering, the University of Western Australia. The focus of my research is to develop reliable and sustainable technologies for offshore cables and pipelines, a key infrastructure for extracting energy from the ocean. The exciting aspect of my job are, firstly, we often find more problems than solutions. And secondly, the solutions that we develop through research do add values to the industry, and more importantly, help in reducing the environmental footprint of energy extraction from the ocean. The things I like to do a bit more is to use the field a little bit more to understand the problems better. We do the testing in the laboratory, we do simulation on the computer. It doesn't really reflect the reality. If we can use the field observations, and that will help us to make the design more reliable, more relevant.
My name's Alice Clark. I now work at the University of Queensland's Sustainable Minerals Institute. The focus of my current research is around taking natural systems, understanding how they work, and applying that knowledge to the mining and mineral processing area. The most exciting thing is the explosion in biotechnology, to take that knowledge and to put it into the ability that we now have, understanding so much about natural systems. As humanity moves towards a low-carbon future, there'll still be a need for minerals to be mined and materials that come from the products of mining. I'm very lucky to be in the role that I'm in, and very lucky that we have so many people that we can collaborate with, both within the university and with a number of other institutions that we work with.
I'm Willy Wanopoul. I'm currently the Dean of Engineering here at the University of Sydney. My main current work is in what's called storage systems, building systems that can store large amounts of data, and that become a very interesting area to work in because there just is a whole lot of data right now and it needs to be stored somewhere. So there's lots of business for us storage researchers right now. The exciting thing in the field of storage systems is two things, really. First of all, there's a new technology that's going to revolutionize how we store data in computer systems.
And secondly, there's a whole lot more data. We're producing data at a rate that grows every day. And so the two together make for some really interesting challenges. And also some really interesting opportunities to do things in a new way and to create new companies and just do a whole bunch of things differently.
On behalf of the Academy, I'd like to congratulate you on your election to the fellowship and welcome you to ATSE. It is a great honor to be elected as a fellow of this Academy. You have competed with the elite of the elites, and that makes you someone who is truly excellent, which is recognized by the fellowship. However, it's not enough just to be a fellow of the Academy. We do need you also to help us with our mission, and that mission is to have an impact on the society in which we live. We want to improve the technological progress of Australia through evidence-based advice, and we need the expertise of our fellows to build up that evidence-based advice and to come up with positions that enable our governments and our population to understand the ways in which we can improve the society we live in.
Thank you to all of our new fellows for giving us a taste of the amazing work that you're doing. Your fellowship with the Academy recognises your vision, your leadership and your excellence. The Australian Academy of Technology and Engineering is proud to celebrate Australia's outstanding talent across the fields of technology, engineering and the applied sciences. We look forward to collaborating with you to continue the Academy's work to help Australians understand and apply technology to the benefit of society and the environment. Before we wrap up for the evening, I'd like to take this moment to thank all of our partners for your contribution, because it's with your support that we're able to celebrate the induction of our new fellows with everyone tonight. Thanks everyone once more for joining us, and from all of us at the Australian Academy of Technology and Engineering, welcome to the Academy.